All right. Hey guys, I hope you had a great spring break. Just don't forget that tomorrow night at midnight, so April 12th at midnight, that your Delta Math assignment is due. Okay, so you're supposed to be working on that over spring break. If you didn't get that done, you got time in class today in the afternoon session to go ahead and make sure that you take care of it. So today we're going to do a couple of things with absolute value. If you missed some of the notes before spring break, make sure that you go back and copy those down. I'm gonna post a video on that just in case if you need it a little later on today. Okay, so notice and wonder. What is one thing that you notice and one thing that you wonder about this equation and graph below? So really quick, just kind of look at it and try to make one connection. All right, one thing that I noticed is that they've got these little pieces out here. So it's the same, similar equations, but they've got these two pieces that are the same. Okay, so from x equals 4 on the right-hand side, when it's greater than, it's this, it's this equation. If it's less than 4, it's this equation. Okay, and one thing that you want to pay particular attention to is this equal to symbol. Okay, I know a lot of us forget which symbol we're looking at. Remember, this is less than and this is greater than. Okay, this is less than and then this is greater than. The way my teacher used to teach me this is the alligator symbol, so like the opening of the alligator mouth, is facing towards the larger number. Okay, so with that being said, we're going to go to the note taker. There we go. Okay. All right, so go ahead and write down this right here. One great thing about this is you can type this straight into Desmos, so I'm going to show you how to do that, but go ahead and write down this equation, and we're going to graph it and then write the absolute value function as two separate equations. So these are known as piecewise functions. So piecewise functions are pieces of a function that are all put together to represent one function. Okay, it's not continuous. There's a discontinuity that goes on there. So that's something to keep in mind. So go ahead and write this equation down, and I'm going to show you how to graph this in Desmos so it can make your life a little bit easier. So when you go into Desmos, okay, we've got 2, and this symbol right here is absolute value of x minus 4. So absolute value means that no matter what number you plug in, at the end, you're going to take the absolute value of it and then multiply it by 2. So we got 2 absolute value. Okay, so the way you're going to do that is you're going to say 2, and then you're going to hit shift. And then there's a button that has the backslash. Okay, so the backslash looks like this. Okay, so you're looking for the button that looks like this. It's normally right above your enter symbol or enter key on your computer. Okay, so backslash, and our equation was x minus 4. We got x minus 4, and then we're going to close that by hitting shift and then that backslash again. Okay, so here is our graph. Now we can see right here at x equals 4, at x equals 4, we got 2 separate equations going on. Okay, so we know that when x is bigger than 4, it's going to be one thing. When x is less than 4, it's going to be one thing. Okay, so let's look at when x is less than 4. That's this piece right here. Okay, so we're going to write an equation for that, just like how you would normally write like a linear equation. Okay, what I would do is I would zoom out just a little bit. Okay, and we can see that it touches the y-axis at 8. So that gives us our y-intercept. Okay, and then it goes down 2 and over 1. Okay, so I'm going to write that down. So it goes down 2 and over 1. So that's going to be negative 2x plus 8. Okay. I always like to check and make sure that my work is correct by plugging in a number, making sure it works. So I plugged in 2, I would get 4. So that works for this equation. Okay. So I want you to take a moment and pause and go ahead and try to write for this equation. What would it be? Okay. So in order to write this, we're going to have to figure out what our slope is. So our slope is from this point to this point, we went up 2 and over 1. So that's going to be 2x, and it's positive. Now this one's going to be a little bit harder to see, but you're going to have to figure out what the y-intercept would be, which is if I continued this line going down, okay, then it would cross the y-axis at -4. Because look, I go 2 down and over 1. I would go 2 down. Oop, it would go a little bit farther than that. Sorry. Hang on. Let me zoom out really quick. So let's zoom out just a little bit. And there's different ways you can solve this. It's kind of up to you how you want to do this. So if I went 2 down and over 1, so I went 2 down over 1, that'd be here. 2 down over 1, that'd be here. 2 down over 1, that'd be here. And 2 down over 1, that'd be here. Okay, so this would cross at -8. My bad. Okay, so this would be -8. Okay, now normally what you're going to do is you're going to pick which one you want it to be equal to. Okay, so kind of like on our last problem, our notice and wonder. I'll go back to that. On our notice and wonder, they picked this one to be equal to. That means when we plugged in 4, that would give me 3. When I plugged in 4 here, it would also give me 3. But this one is the one that they picked. I would normally pick the one that is, for instance, I would pick the one that's normally continuing to the right side. So the greater than. So this one right here, I would put an underline. One of them has to be equal to if there is a point at that spot, okay? Now, one thing that you want to make sure that you do is you always want to put this in like little brackets. Sometimes you'll see them as brackets, sometimes you'll see them as parentheses. This is stating your domain, essentially, okay? It's saying x is greater than or equal to 4, x is less than 4, okay? Coming back over here, you would plot this on your graph, and then you would write out this equation. With piecewise functions, what happens normally, I'm gonna get rid of all this junk. What happens normally with piecewise functions is they're written out with this big bracket. So you'll see f of x equals this bracket, and then they'll write out all this information. And they have to include this x is greater than or equal to 4, x is less than 4. If they don't include that, then it's not a complete piecewise function. All right, so go ahead and take a look at the next one. So write an equation for the following piecewise function. So notice how this is all broken up into like little pieces. Okay, so I want you to try to write an equation for each piece. And notice how they have dots on the end of them. Okay, so that's something to keep in mind. If it's an open circle, that means it's an open interval. And I'll explain that in just one second. If it's a closed circle, that means it's a closed interval. Okay, so that you have to pay attention to. So this is a closed circle, and this is kind of hard to see. This is open, and then this has an arrow, and this has an arrow. All right, so if I'm writing a equation for this, I'm gonna look at this piece right here first. Okay, so how do I write an equation for this line? Well, it's a straight line that goes horizontal. So that's going to be y equals -2. And where does that actually occur? Well, it happens from -3 to negative infinity, right? So it's less than -3. Now, since it has this closed circle, I'm going to show you how we're going to write that. We're going to say x is less than -3, but we're going to put an equal to piece. So closed interval is going to be equal to. Another way you can kind of maybe see this isn't written like this quite often, but it's very similar to how you would say -infinity to 3, and you would use a bracket. That's a closed interval. And that's actually how we're going to write. We may write on the next one, but I just want to make sure that you know that. Okay. So then the next piece we're going to look at is this piece right here. Okay. And so we're going to write an equation for this line. Well, our y-intercept is 4. Okay. And it's going up 1 over 1. Okay. So our y-intercept is 4. And it's going down 1 over 1. So this is going to be -x plus 4. Okay. Now, where is that happening from? Well, it's happening from -3 to 0. Okay, so I'm going to use a different color so you can actually see this. From -3, you're going to put the x in between to 0. Now, notice how I didn't put any lines underneath. That's because it's an open interval. Okay, so if it's an open circle, no lines. If it's a closed circle, there is going to be a line. Okay, so that's -x plus 4. Okay, and on this last one, it would be the y-intercept is 0. So we're going to just put plus 0. And it goes up 1 over 1. Okay, so x plus 0. Or you could just write x. Now, where does that happen from? 0 to positive infinity. So when x is bigger than 0, and it is on a closed interval, so we're going to say equal to. Okay, so how would you write this out at the end? Well, you would write f of x is equal to, and you would say the bracket. Normally, instead of it being y equals -2, we would just say -2, comma, and we would say x is less than or equal to -3. And then we would say -x plus 4, -3 to 0, and x, and that would be x is greater than or equal to 0. So that's how you would write it out at the end. So go ahead, again, pause the video, go ahead and try to write this one out. Okay, each piece is in a different color. Okay. All right, so let's try this one. Okay, this equation right here is the y-intercept would be 0, and it's up 1 over 1. So this is going to be x, y equals x. Okay, and where is that occurring from? Well, it's happening from -3 to -1. And I'm going to go ahead and assume -3 to -1. And I'm going to go ahead and assume that there's lines underneath this first one. Because on that second one, we kind of see where that blue overlaps, right? Okay, so we see how that blue overlaps on that -1. So we're not going to put a little bar underneath. Okay, on this next one, that's a line y equals 1. Okay, so we're just going to put 1 right here. And that goes from -1 to 0. So -1, and that's inclusive, to 0. And that's not inclusive because we got this green, right? So this equation right here, again, is up 1 over 1, but the y-intercept is at 1, -1. So this is going to be x minus 1. And that's going to be from 0, inclusive, to 2, not inclusive. Okay, again, the reason why I'm making that assumption is because this black line is overlapping that green line. Again, one of them just has to be touching that. Okay, this line right here, okay, we see that it's going down 1 over 1. So if I continued that process, I would have 3 as my y-intercept. So I'm going to go down 1 over 1 by saying negative x plus 3. And that's happening from 2 inclusive to 3. And that's also inclusive because there's a point right there. Okay. I know these are a little tricky. The one thing to pay attention to is your domain. So all of that stuff on the right-hand side. That's normally what you'll get tripped up on your questions. Okay, so if you go back to today's stuff, if you open up this student choice board, what you're gonna see is this stuff right here. And so what you're gonna do is you're gonna pick one of these to complete. Okay, so you can do the domino challenge, you can do the lava challenge, or you can do just the writing piece functions practice sheet. Now on the domino challenge, what I've done is I have included the answer key right here. Okay, so this is just for you to be able to make sure that you understand this stuff. Okay, there's also a Desmos activity if you'd like to complete it. That's the lava challenge. Okay, so there's 7 little slides. Okay, or you can just work on your piece of paper and complete by writing piecewise functions. If you got a question on any of this, just send me a screenshot of it through Remind and just let me know what questions you have. Okay. The last thing that we have is a little 2-minute write. Remember, whenever you have stuff on eClass, make sure that you right click and open in a new tab. We love our eClass. And yeah, you can make a copy. Just make sure that you're signed into your G Suite account. Otherwise, it won't let you do it. All right, so write down 2 to 3 details that a piecewise function tells us about a piecewise graph. So when you look at the graph, what conclusions can you make about the graph? Okay, so basically, what do we do for our notice and wonder? Okay, these are good to do for just summarizing what we did in class. Okay, again, final reminder, remember that your Delta Math assignment is due tomorrow by 11:59 p.m. It'll really be helpful towards your grade, so please make sure that you get it done. There are no extensions, so please make sure that you get it completed. Okay, all right, I'll see you in the next video.